Let's first understand the problem. We'll be given an integer array height that is of length n, and elements of the array will represent height of ith line. We have to find two lines that will contain the maximum water, and we have to return that maximum value. Here the given array height is 1, 8, 6 and so on to 7, and ith element of this height array is the height of the line, that is I and height of I. So the first element 1 represents a line for 0th index of height 1, that is 0 to 1. Similarly, the second element 8 will represent 1 to 8, 2 to 6 and so on. Here we have to find two lines that will contain the maximum water. Here the indexes 1 and 8 will contain most water, that is of height 8 and 7 respectively. So the maximum water these two lines can contain is 7 into 7. The height of the water can be of maximum 7 because anything more than that will overflow. So this is a square, and height is 7 and breadth is also 7. Area of the water will be 49. If we assume index 1 as I and index 8 as j, then we can create a formula that would contain most water between any two lines. That would be j minus I, that is 8 minus 1, into minimum height of ith index and jth index, that is minimum of height of I and height of j. In this case that is 7. So this is containing 49. Let's try to think of a solution for this. So we have to find two lines that would contain most water. The easiest solution we can think of is iterating over all the possible combinations, calculating the maximum value for the max area and returning that. So for that, let's first declare a variable, let max area, and we'll define it to 0, because if there is no element in the array, that means the height is empty or the height contains only one line, then that can't hold any water, that would be 0. Then we'll iterate over all the possible combinations. So we'll take two variables to be iterated, I starting from 0 until length of the array, keep incrementing. Then we'll take another variable, let j equals to I plus 1. We'll start from one element greater than I. We'll go until length of the height, keep on incrementing j. So here we're fixing I in one index and keep moving j from I plus 1 until the end. So we are calculating the water that can be held with line 1 and 8 of height 1 and 8, similarly 1 and 6, 1 and 2 and so on to 1 and 7. Don't need to move I until the end because one line can't hold any water, so we can change it to -1. Now let's calculate the area that can be held between index I and j. Area would be difference between j minus I into minimum of two heights, that is height of I and height of j. Now we got one area. Now we have to check if this area is the maximum. So we can check max area equals to maximum of current max area and the current area. So in the end, max area will contain the maximum value, and instead of -1 we'll return max area. Now let's check if this solution works fine. Well, this passes all the test cases. If we check the time and space complexity of this program, then there are two for loops that are nested, and the first for loop is starting from index 0 and going until the height of the array, that is n. So the time complexity for this is O of n. Similarly, the nested for loop is also of complexity O of n. By combining both the nested loops, the final time complexity is O of n into O of n, that is O of n square. There are no extra space used here, so the space complexity is O of 1. Can we optimize the current solution? The area between any two lines is difference between indices of I and j and multiplication of minimum height of any of the two indices. So area directly depends upon the difference between I and j. If we start from indices 0 and 8, so the width of the area will be maximum, that is 8. For this container, the max area is 8. If we move index 8 to 7, then it will not have any effect, because the height of the 0 is 1, which is less than 7. It doesn't matter if the next index 7 has more height than index 8, because the height of the container will be constant. So you have to move index 0 to the next index, that is 1. Right now index 1 has more height than index 8, but still if the index height of index 1 is less than index 0, then there is a chance that the next index 2 might have greater height than index 8. So we'll move index 0 to next height, index 1. The area of this container is 49. Similarly, index 8 has less height than index 1, will decrement index 8 to index 7. Now this container has area of 7 minus 6 into 3, 18, which is not greater than 49. So our max area is still 49. Now between index 1 and 7, 7 has less height, so we'll move it to index 6. This container has of area 5 into 8, that is 40. 40 is still less than 49. Now both the heights are same. Let's move 6 to index 5. Any will do, but we'll move 6 to 5. Now this container has area of 4 into 4, that is 16, which is less than 49. 5 height of 5 is less than 1. We'll move 5 to 4. Similarly, 4 has less than height 1. We'll move 4 to 3. Then 3 to 2. Still the height is 6 into 1, 6, that is less than 49. So we got our result as 49. The approach we discussed is called two-pointer, because we are taking 2 points in that single array. We are keeping one index constant and we are moving another index. There are multiple variations of two-pointer that we will discuss in the next video. Let's code the two-pointer solution. We'll take two variables as two pointers. One will start from the 0th index and another from the last index. We'll take two variables, I starting from 0 and j starting from length of the height minus 1. We'll take another variable, max area, which will contain our result. We'll move both I and j towards themselves until they collide, that is while I less than j. Then we will calculate area between these two indices I and j, that would be j minus I into minimum of height of I and height of j. And the max area would be maximum of max area and current area. Now we have to move I and j. We will move that index which height is lesser. So if height of I is less than height of j, then we'll increment I, else we'll decrement j. In the end, we will return max area. This passes all the tests. Onto the time and space complexity of this program. Here we have only one while loop. We assume j is the maximum, then I will be moving from start index 0 to last index. So the maximum iteration possible is n, that is length of the height. So the time complexity is O of n, and there is no extra space used, that is proportional to length of the height array. So the space complexity is O of 1.